Yes, even more circles. We are going to be doing tonight different parts of a circle, continuing with our discussion of shaded areas. So if you're on this page in the notes, we are going to be talking about the three shaded areas that you see there. So having learned how to calculate the area of a circle, we use visual thinking and problem-solving skills to calculate areas of different sections of a circle. If you think about a slice of pizza, that's actually got a proper name, and that is a sector of a circle. So the next time you ask for a slice of pizza, you can say, "May I have a sector of the pizza, please?" Some other sections that we're going to be considering are segments and the annulus. A sector of a circle is the region between two radii and an arc of a circle. A segment of a circle, I know that sounds kind of strange, but it's bounded by a segment that is a chord of the circle and an arc of the circle. And this area is actually called the segment. And the annulus is kind of like your target or your bullseye, and that's concentric circles. And we can talk about two concentric circles. I drew three there, but if you look at this picture, this area here. Okay, so like a donut shape or a Cheerio. So think about the number of degrees in a complete circle. We're going to be using fractional parts of a circle, kind of like using ratios, to discuss these areas. So the total number of degrees in a circle is, drum roll please, 360 degrees. We can use fractions to help identify the part of the complete circle we're referring to. So if you look at the picture that's drawn, what is the fractional part of the circle shown? And all of you should be saying, "Oh, that's easy, it's 1/4. Well, how do we know that for sure? This is how we know it for sure. We know it for sure because that angle is marked 90, and 90 over 360 is in fact 1/4. So that's how we know for sure that that's a fraction, a 1/4 fractional part of the circle. So if the radius is 14, what is the area of the circle? Let's do in terms of pi, the exact area. All right, so the exact area of the circle is going to be pi r squared. Well, that's going to be pi times 14 squared, and if you know your perfect squares, that is 196 pi millimeters squared. That's the area of the whole circle. Now the fractional part, the sector, the area of the sector is going to be the number of degrees in the angle. So the degrees in the angle we're using over 360 times pi r squared, because we're going to take that fraction. So this is 90 over 360 times what we already knew was 196 pi. Oops, that's a 6 pi. And if you do that math, you get 49 pi millimeters squared. So let's try a couple of these examples. If you'd like to pause here and try them on your own, that might be a good strategy, or you can walk with me on one of them and then pause after that. So again, the area of a sector is going to be the degree measure over 360 times pi r squared. So in this case, it's 60 degrees over 360, which is just 1/6, times pi times 6 squared. And you can go ahead and work out the math there. And the area of the sector is going to be 6 pi centimeters squared. So you might want to try one of the next ones on your own. Now, keep in mind, you can't really see the shaded region. You can kind of see it on my video here, but this is the area that we're talking about. So you have to get the appropriate angle. They're showing me this 240. I don't really care about that. I want to know what that angle is right there. I want to know what this angle measures. Well, I know that if this angle is 240, this angle has to be 120 to add up to 360. So for my formula, the area of the sector is going to be 120 over 360 times pi times 8 squared. Okay? If we do the math there, try and work it out, leave it in fractional form, and I would get 64 pi over 3 centimeters squared. Believe it or not, I know that looks messy to you, but it's a learning process. That's the answer that I would prefer. It's exact. It's not an estimate. All right, so in this case, if I know that this is 90 degrees, then what I really want to know is, what is this angle? That angle has to be 270 degrees. So that's the angle I'm concerned about. So my area of my sector is going to be 270 divided by 360 times pi times 16 squared. All right, and that is going to be, do the math, and I get 192 pi centimeters squared. I really hope you guys are pausing here to do some of this math on your own, because I'm not going to be there to help you when you have your quiz. I'll be there to help you, but I won't do the problem for you. Okay, moving on. We just did the area of some sectors. Now we're going to talk about the other two. And actually the first one here, try this one on your own, because that's just a sector. So let's do that one first. Well, the area of the sector is the degree measure of the angle over 360 times pi r squared. So that's 45 divided by 360 times pi times 20 squared. And if you work out all of that math, you should get 50 pi centimeters squared. Now, the next few, or the next two anyway, are the segments. Now, if you think about a segment, we have to really dissect what that means. We're talking about the area of this sector being broken out into two parts, being broken out into a triangle plus kind of a little boat shape there. Okay, this is the segment. So if I subtract the triangle part, if I subtract this triangle out of my sector, then I'm left with that part that I want, which is this. Okay? So we have to actually find the area of the sector minus the area of its associated triangle. So if I go down to an example here, number 2, what I want to do is I want to find the area of the sector minus the area of the triangle, and that's for the area of the segment. Okay? So the area of the sector, remember, is the degree measure, which is 90, over 360, times pi, times the associated radius, which is 6, minus the area of this triangle. If I take that triangle out of it, then I'll just be left with this, which is what I want. So the triangle is 1/2 base times height, which is 6 times 6. This question actually asks us to round to the nearest tenth. Not my favorite, but I'm going to work it out anyway to show you. So I'm going to get 9 pi for this part, minus 1/2 of 6 times 6 is 18. And so then rounded to the nearest tenth, I get 10.274333388. So I don't care about anything other than the hundredth, which is a 7, which gives me a 10.3. And that is centimeters squared. Now the next question is kind of interesting because they ask us for the angle and they give us the area. But we have our handy dandy little formula, and this one just relates to a sector. So I can use my handy dandy formula for my sector and back into that angle measure. So the area of a sector, remember, is the degrees divided by 360 times pi r squared. Well, I know that the area is 14 pi. I know the radius is 6. So I'm going to plug that information in. So I'm going to put in a 14 pi here equals. My degree measure is what I do not know. That's my x. Okay? So x divided by 360 times pi times 6 squared. And then we're going to just simplify this. It's simplifying algebra. So 14 pi equals x divided by 360 times 36 pi. Well, I see that I can cancel something here, so why not? I'll cancel my 36 into the 360, and that's going to give me 10 here. So simplifying a little further, I would get 14 pi equals x over 10 times pi. And now I'd like to just divide both sides by pi, essentially. So that's like multiplying this by 1 over pi and multiplying this by 1 over pi. And so then my pi's cancel. And I am left with 14 equals x over 10, and x equals 140 degrees. And that would make sense. Go back to your picture and look, because a 90-degree angle would be here, a 180 angle would be here, and so that's about 140. But pictures aren't always drawn to scale, but sometimes we like to look and make sure it makes sense. Okay? Now tomorrow we're going to be looking at that next page in your packet with those fun things. So you might want to peruse that sheet so you can come in with some good questions for me. I'm not asking you to do any of them, but just in case some of them you think you might not be able to do, we could start as a class with those together to get you started. Okay? Have a great night, everyone. See you tomorrow.